Hello everyone, this is Math Abdali from ACE Exams. Today I'll be explaining topic 5, which is the topic that has the most calculations in A-level chemistry. Now, in this video, I haven't explained everything that is in topic 5. I have chosen the questions and the topics that are more tricky and are most likely to come in the exam. So basically, for your exam, I don't advise you to only use this resource to revise for your exam. I advise you to practice more exam style questions, because basically for topic 5, the more you practice exam style questions, the more you perfect this topic, because it's full of calculations. Now, the mole. So mole is the unit of amount of substance. These are the things that you have to for the mole. So Avogadro's number is 6.02 times 10 to the power of 23. Number of particles can be calculated by multiplying the number of moles with the Avogadro's number. Mole can be calculated from mass and MR, which is the molar mass, or AR. You can call it either AR or MR. MR is for molecule, and AR is just for atom. Mole equal to mass divided by MR. Mole equal to concentration in mole per dm cubed times by volume, which is in dm cubed. Concentration is mass divided by volume. Now this concentration is if it is in gram per dm cubed. This concentration is mole per dm cubed. So if you wanna find the concentration in grams per dm cubed, then you just have to divide mass divided by volume. Divide volume by mass. Mole equal to volume divided by the molar volume of gas, which is 24 dm cubed per mole, and the volume is in dm cubed. Now, if the volume is in centimeter cubed, you could change the molar volume of gas into 24,000, because basically 1 centimeter cubed, no, sorry, 1 decimeter cubed is 1000 centimeter cubed. Yeah, 1 decimeter cubed is 1000 centimeter cubed. So from decimeter to centimeter, from decimeter cubed to centimeter cubed is times by 1000. Now, if you just have decimeter and centimeter without the cubed, is multiplied by 10. But since it's cubed, it's times by 10 to the power of 3. So that's why it's times by 1000. Now, a mole equal to PV divided by RT, where P is the pressure in pascals, a volume is in meter cubed, R is 8.31, and temperature is in Kelvin. Now, most likely in exams, they might give you the pressure in kilopascal and you have to convert, and sometimes they give you the volume in centimeter cubed and you have to convert it to meter cubed. So you have to be very careful in terms of calculations. They might give you the wrong unit and you have to be very careful and get the right units. Now, we have an exam style question in here. So it says that green oxide, an ore of cadmium, contains 45% by mass of the metal. Calculate the number of atoms of cadmium in 2.05 kilograms of the ore. And the Avogadro's number is 6.02 times 10 to the power of 23. They give you that in exam. So first thing is that you have to convert the 2.05 kilogram into grams. So 2.05 times that by 1000, which is 2050 grams. And then it says that this contains 45% by mass of the metal. So you have to multiply this by 45%. 45%, which is 45 divided by 100. And then that should give you 922.5 grams. And then after that, you know that mole equal to mass divided by mR. So you do mole equal to mole equal to mass, which is 922.5. And on the periodic table, cadmium, it has an MR of an AR, sorry, of 112.4. So 922.5, divide that by 112.4, which should give you 922.5, then divide by 112.4, which should give you 8.207 mole. But the question says calculate the number of atoms. So if they tell us that we have to calculate the number of atoms, then we have to multiply by the Avogadro's constant, which is 6.02 times 10 to the power of 23. And then that should give us an answer of 4.94 times 10 to the power of 24, to 3 significant figures. Okay, so this is a more calculation question. In this question, it says that an experiment was carried out to determine the relative molecular mass of a volatile hydrocarbon X that is a liquid at room temperature. A non-mass of X was vaporized at a non-temperature and pressure, and then the volume of gas produced was measured in a gas syringe. Data from this experiment are shown in table 1. So in this table gives us the mass, temperature, pressure, and volume. Calculate the relative molecular mass of X. Show your working, give your answer to appropriate number of significant figures. And the gas constant is 8.31 joule K to the power of -1 mole to the power. So in this question, it tells us that we have to work out the MR, which is the relative molecular mass. So we have to use this equation, N equal to PV over RT. But we have to convert. So pressure is over here, it's given in kilopascal, and then we have to convert it to pascal, which is 102 kilopascal is equal to 102 times by 1000, which is 102,000. Volume is given in, that is pressure. Volume is given in centimeter cube, and we have to convert it to meters cube. So we do that by dividing 72, dividing it by 100 cubed, which gives us an answer on the calculator. I think 7.2 times 10 to the power of -5. R is 8.31. It's given in the question in here. And temperature, it's already given in Kelvin. Now, if they give us the temperature in Celsius, all we have to remember is add 273. I'm just going to write that down. So from Celsius to Kelvin, add 273, and we just input that into the calculator. 102,000 times by 7.2 times 10 to the power of -5, divide that by 8.31 times by 373. That should give us an answer of 2.369 times 10 to the power of -3. That is the number of moles. But in the question, it says that we have to find the MR. So mole, we know that mole equal to mass divided by MR. So MR is mass divided by mole. Mass is, oh, it's given in the question, but it's given in milligrams, and we have to convert it into grams. So divide that by 1000, which is 0.194, and 0.194, divide that by 2.369 times 10 to the power of minus 3, which gives us an answer of 82, to appropriate number of significant figures, because over here the lowest number is given in 2 significant figures, so just give the answer in 2 significant figures. And the unit of that is grams per mole to the power of minus 1. Oh, sorry. Okay, so this is the empirical formula, which is the simplest whole number ratio of element in a compound. Again, this is another calculation question. Well, we have to follow these steps, and then we should get a right answer then. So the step says, write down the elements involved, write down the percentages as masses, divide these by their relative atomic mass to get them all, then divide all the numbers by the smallest number of mole, and that is to work out the empirical formula. If you want to work out the molecular formula, we just divide the MR of the molecular formula by the MR of the empirical formula. So in here, it says that the hydrocarbon with the relative molecular mass of 28 grams per mole has the following composition: carbon 85.7 percent, hydrogen 14.3 percent. Calculate its molecular formula. So in this question, carbon has a percentage. You just have to basically do a table, and then from there we can work it out. So we know that a hydrocarbon has carbon and hydrogen only, so carbon and hydrogen. So carbon has a percentage of 85.7 grams and 14.3 gram, because in here it says write down the percentages as masses. And then after that we have to divide these by the relative atomic mass. So carbon has a relative atomic mass of 12, and then hydrogen has a relative atomic mass of 1, so MR, and then this one is write down mass. And then we know that mole equal to mass divided by mass, so 7 divide that by 12 we use 7.14, and then over here 14.39, and then from there we have to divide these numbers by the relative atomic mass. Oh, we already did this step. So divide all the numbers by the smallest number of mole, which is 7.14 in here. So in here 7.14 divided by 7.14 is 1. Divided by 2.05. Let's just say 2. And then the molecular formula is CH2. Now this is not the molecular formula, sorry, this is the empirical formula. But to work out the molecular formula, we have to work out the MR of the empirical formula, which is 14, because 12 plus 2 is 14, and then 28 divided by 14 is 2, and then we have to multiply 2 by the empirical formula, so it's going to be C2H4. Skeletal formula and combustion analysis. So this is the tricky part of chemistry as well. I mean, many different questions could come up on this, but I have picked out the hardest question I could ever find, and yeah, just show you guys how to work it out. So, Skeletal formula, very easy, because all you have to do is look at the blank spaces and look at the I don't know how to explain it. Just look at the blank spaces and just write down C. And then over here, C, 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 C. And then we know that like C should bond with, and then carbon has 4 bonds, so there's one, two, so the 4 bonds should be hydrogen. This one is with hydrogen as well. This one is with hydrogen. This one is 1, 2, 3, 4. 1, 2, 3, 4. Hydrogen. 4. Nitrogen has 3, 1, 2, 3. Carbon has 4 already. It's already there. And then C is hydrogen. And then another hydrogen in here. Another hydrogen in here. Another hydrogen in here. And then you have to calculate the number of C, the number of hydrogen, the number of oxygen, and then the number of nitrogen. So C in here should be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 18. Hydrogen is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hydrogen. Oxygen is 1, 2, 3, 4. 1, 2, 3, 4. 4. And then nitrogen is just 1 nitrogen. And then that is the molecular formula. Now in here it says that on combustion 1 gram of Q, which is this one, produces 2.614 grams of carbon dioxide, 0.2673 grams of water, 0.04620 grams of nitrogen. Use this data to calculate the percentage composition by mass of Q and hence its empirical formula. Show whether your answer is consistent with the molecular formula of Q. So I love this question because it has many mathematical parts, and I love maths. So CO2, you have carbon dioxide, H2O, and nitrogen. And so first step is to work out the amount of carbon. I mean the mass of carbon. But so the first thing you have to do is find the amount of carbon on the periodic table, which is 12, and then what is the amount of carbon dioxide, which is 12 plus 16 plus 16, which is 44, and then you multiply this by the total mass, which is of carbon dioxide, which is 2.614, and then that should gives you a mass of 0.713 gram. Hydrogen is 2 divided by, just do the same thing, 18, because 2 plus 16 is 18, times by the total mass, which is 0.2673, and then you should get an answer of 0.0297. And nitrogen is 0.4620. It's already given in the question. And then oxygen, all you have to do is we know that the total mass is 1 gram, so we know all you have to do is 1 minus 0.713 plus 0.0297 plus 0.04620, and then you should get an answer of 1 minus 0.713 plus 0.0297 plus 0.4620, and that should give you, hold on, just give me a second. Yeah, that should give you 0.2111, and then you do another table because I don't have enough space in here. So carbon is 0.713, hydrogen is 0.0297, nitrogen is 0.04620, oxygen is 0.2111. The next step is you have to divide that divide this by the mol again. So carbon is 12, the mol of carbon is 12, mol of hydrogen is 1, mol of nitrogen is 14, and mol of oxygen is 16. And you divide it, you should get an answer of 0.0594. This one is 0.0297, and this one is 0.0033, and then this one is 0.211 divided by 16, 0.0132. And then you have to divide this by the smallest number, which is 0.0033, and 0.594 divided by 0.0033 is 18. This one should be around 9. This one is 1. 0.0132 divided by 0.0033. This one is 4. And then these are the numbers. So C18, H9, N is 1, and then oxygen is 4. And it is the same one as here. So basically this is actually 6 marks because you already know that your answer is right. You got the same answer in part A and part B, and if you get the same answer, it is right. Show whether your answer is consistent with the molecular formula of Q, and it is consistent because yeah, it's consistent because it's the same. So next question. Okay, ionic equations. So first thing you have to do in this question is, in these type of questions, is break down the questions into different ions, and then later on you can cancel the, just cross out the spectators. Now this equation is 2k MnO4 plus 16 HCl plus, no, the arrow, 2 MnCl2 plus 5Cl2 plus 8 H2O plus 2KCl. This is aqueous, by the way. And first I'll write it down. MnO4 aqueous plus 16 H2O minus aqueous. Arrow 2 Mn 2 plus and aqueous plus Cl minus aqueous plus 5 Cl2 plus 8 H2O aqueous, no, liquid, sorry. If it is liquid, solid, or gas, it stays the same, you don't change it. Plus 2 2k plus aqueous plus 2cl minus aqueous. And then you cross the spectators, so 2k plus 2k plus 16CO. That changes into 10cl because this one is going to get crossed and this one is going to get crossed. Hold on. This one is 4, by the way, not 2. Sorry. 4cl2. This one is going to get crossed. This one going to get crossed. We don't change this one. This is different. This is different. And then yeah, that's it. Aqueous plus 16H plus R2 N2 plus 8H2O aqueous liquid. And yeah, that's it. So this is the hardest part of topic 5, which is titration. Now, the first thing that you have to do in titration is drawing a diagram, because in the chemistry exam there is no there's no like thinking time, if I'd say. Basically, you have to be very peaceful and careful at the same time. But yeah, be very careful because the chemistry paper is about like 100 marks for like 2 hours, something like that. 2 hours or 2 hours 15 minutes, one of the two. And it's like too many questions, so you have to be very speedy. So the first thing you have to do in this question is draw a diagram. So you have a mass, and at the same time you read the question carefully. So phenolic acid carried out a titration to determine the mass of the acid in the solution. So we have to work out the mass which is in here. And okay, so flask and then a burette. Okay, so the first thing that you have to do is convert this into decimeter cubed. So 25.3, divide that by 1000, multiply this. So this is the decimeter cubed. Multiply this by 0.5, so you could get the mole, which is 0.01265, and then this one is the mole of sodium hydroxide solution. And then if you want to find out the mole of ethanoic acid, you have to multiply this, so 0. In here, 0.01265 times that by 25.3, divide that by 25, and then you have to divide that by 2, because from sodium hydroxide to ethanoic acid is divided by 2. So imagine you're doing the titration and look at the question for like the equations and stuff like that, and then that should gives us a total of 0.006325 mole. And then this is the mole, and then in the question it says you have to calculate the mass in milligrams. So you know that mole equal to mass divided by mole. MR of ethanoic acid is, you figure that out, which is 2 plus 2 times 6, 2 times 16. No, 2 times 12 is 24. Oxygen is 16. Yeah, 4 times 16, which uh, which is 4 times 16, 90. And then from there you do 0.006325 times that by 90, and then it's gonna equal to 0.576 grams. But the question says calculate the mass in milligrams, so you multiply by 1000 and you should get an answer of 576 grams. Okay, thank you very much for watching the video. Thank you very much for listening. See you in the next video. Make sure to stay safe, and happy new year. Bye bye.